Now let's consider 3.71. The problem reads, potassium nitrate decomposes upon heating, producing potassium oxide and gas phase nitrogen and oxygen via a reaction that's given and balanced. To produce 56.6 kilograms of oxygen, how many moles of KNO3 and how many grams of KNO3 must be heated? All right, so this is another stoichiometry problem. It's a little bit different than the previous one we worked because there we were given the amount of our reactant, not just how much product we can make, but we can also do things the other way. We can be told how much product we want to produce and then be asked how much of our reactant is required to make that much product, okay? Again, it's kind of like kitchen chemistry ingredients. How much cake can you make? Well, it depends on how many ingredients you have, right? Chemical reactions work a lot like that. It's very quantitative in structure. Okay, 4 of these make 2 of these, 2 of these, and 5 of those. Now in this case, we're told we want 56.6 kilograms. Kilograms, right? So if we do the conversion to grams, that's 56,600 grams of oxygen. That's how much we want to make. Now that's a mass, right? Remember, when we're working in our chemical reactions and doing our stoichiometry, we don't want to use mass. And the reason why is because these numbers describe the number of copies or the number of formula units of everything to combine, okay? So we need to convert any masses to moles. And here I can do that by dividing by 32. 32 is 2 times 16. Of course, on the periodic table of the element, you'll find the atomic weight of oxygen 16. I multiply that by 2 to get 32 because we're dealing here with the diatomic oxygen, the O2. That's why I had to multiply by 2. And if I do that, I can quickly find out and compute that I desire to produce 1768.75 mole of my oxygen, okay? That's how much I want to make as a result of this reaction. So the question is well, how much of this do I need to decompose to make that, okay? Well, how can we figure that out? What do you think? I now have a known quantity of one of my products, which is 1768.75 mole. Doesn't it make sense that I can use the ratio of reactants and products from the balanced chemical equation to help me For instance, I know from my balanced chemical equation that for every 4 moles of this stuff that reacts, I produce 5 moles of oxygen. Okay? So it seems like if I want to make this much oxygen, 4/5 as much of my potassium nitrate is going to be what's required in mole units. Okay? So I just have to do that math. And I can quickly then figure out that I require 14-15 moles of potassium nitrate. So that's the answer to one of these questions. Now, the next question is how many grams do I need? This becomes, again, a pretty simple moles to grams conversion. I have 14-15 moles, KNO3. And I need to go to moles, or to grams, sorry. So for every 1 mole of KNO3, I need to know how many grams corresponds to that. And it turns out the molecular weight of KNO3 is 101.11. This is that number that you get if you add up all the parts from the periodic table, the K, the N, and 3 oxygens. You end up getting 101.11. It's the molar mass, or the mass of 1 mole. So I do the calculation, and I get 143.070 grams. corresponds to a little over 143 kilograms. 143.07. This is how much potassium nitrate is required to undergo this decomposition reaction to produce 56.6 kilograms of my oxygen.